In the world of agentic communication, we give a lot of trust to the LLM to make decisions about how to orchestrate a workflow to achieve some end goal or task. That LLM takes context, which is usually the user prompt, a system prompt, tools, and potentially things like RAG, takes that context, feeds it to the LLM, which then influences the decisions. Now, if you get into situations where you have tools that have descriptions that inject malicious prompts, or agents that have names that collide with other agents on purpose because they are malicious agents, or any other sort of indirect injection to the context, can influence and attack your system, leading to things like data exfiltration and compliance issues and security issues. So what we want to take a look at is, how do you onboard agents and onboard tools in such a way that you put them through some sort of approval workflow. This is an example of what some sort of workflow could look like, where you have agents that have been registered with a system and are available in some sort of catalog. The same thing goes for MCP servers or even LLMs. You don't want to just bring in rogue LLMs. But from a tooling standpoint and MCP server standpoint, you will want to vet those MCP servers and screen them for malicious indirect prompt injection attacks, also called tool poisoning. So if we were to try to register a new server here, let's say we go to our Acme goodmcp.com, and so our tool server is running here. We'll fetch the server details. We'll be able to pull up things like the tools and the descriptions for those tools. And what we want to do is kick off a workflow that will check the names, they don't collide with other tools, that the descriptions don't have any poison prompts, and generally go through any other enterprise workflows that we want to check before we vet and accept a particular tool. In this case, we've passed those security checks, and we take a fingerprint of this MCP server and all the tools that it has, so that it cannot change under our, once we approve it, we don't want it to change behind the scenes. That's called a rug pull and is very dangerous. So if we complete our registration and maybe go take a look, we can see that we've added our new MCP server. But let's come in here and let's say we give it a bad MCP server, and we go get those details. We'll send those details to the system. It'll start the registration, check for name collisions, check for poison prompts or prompt injections. And if this finds that there are issues with the tools and their descriptions or the MCP server, then we should catch it here before we approve it and abort this registration. The same thing can be done for agents. So if you have agents approved, we can come in and check for bad agents as well. And if we say next, it'll go get that information from the agent card. We can take a look at the various skills that this agent provides, and we'll verify its security following a very similar flow. And if we detect things like poisonous prompts, then we will want to reject that. We don't want to accept that into our catalog. So this is an example of what a system could look like in your enterprise when you're dealing with governing AI agents, their tools, and the infrastructure around them.